So now we're going to look at our trigonometric functions of any angle. And in order to understand what's going to happen with non-acute angles, angles that are not between 0 and 90, we should try to look at a better pattern for what happens when it is between 0 and 90, given that we're now measuring angles on the xy plane. So in this first one, what we're going to do is take a line segment that goes from 0, 0 to the point 3, 4, and just noticing that line segment has length 5 by Pythagorean theorem, and I can make a right triangle out of it. And I know that this length is going to be 3, and I know that that length is going to be 4. So if I find, and I can find sine theta, cosine theta, tangent theta, no problem. Sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. So there we go. So how does this translate to when we just have an x and a y? Well, let's just see. So I have the same picture, and I'm going to assume, instead of computing the hypotenuse, I'm just going to call it r. And that's going to be a very popular symbol for us to use for that length of a side. So if I find sine of theta, I realize that that is, well, I know that this is whatever y is and this is whatever x is. That's y over r. I know that cosine of theta is opposite over hypotenuse, which is x over r. And I know that tangent of theta is opposite over adjacent. So now we have those expressions for sine, cosine, and tangent. So what I want to do is say, well, so since this holds true in the first quadrant, because I can easily visualize that, I'm going to be able to go to any quadrant and still use that idea. So hence we have a definition. And here we go. There are the 6 trigonometric functions. So xy is any point in the xy plane, could be in quadrant 2, could be in quadrant 1, 4, 3, whatever. Sine of theta is always going to be the y coordinate over r. So we're going to need to know how far away the point is from the origin. And that's a good thing because we know how to compute that pretty easily. That's just Pythagorean theorem usually, or distance formula, however you want to call it. And there we have formulas for all of them. So this is going to open the door to a lot of things. What happens when xy is on an axis instead? What happens when we have undefined values? We'll get there. It's going to be a gradual process for us here. So let's look at, with this convention, let's look at an example here. So let's say that I have a point in the 4th quadrant, and I want to find sine, cosine, and tangent. Well, by looking at the triangle, now again, 12, 5, so that means this is 12 and this is 5. Pythagorean theorem would tell me that this side here is 13. So if this angle right here is theta, starting from the positive x-axis and going almost all the way around, I know that sine of theta is y over r. Y is -5 and r is 13. So, the trig functions can be negative. That's interesting stuff. Cosine of theta, I know from above, is x over r. Well, that's 12 over 13. And tangent of theta is y over x, which is -5/12. So if I know the point where the angle ends, that's on the end of the terminal side, I can easily find the values of the trig functions. No sweat. Let's say we're in the 2nd quadrant. So we have the point -2, 3. And I want to find all 6 of the trig functions. Well, and again, I know that sine of theta is y over r. So here again, I need to know what r is. And by Pythagorean theorem, I'm just going to do this quickly. That side is the square root of 13. So y is 3 and r is root 13, and I'm going to leave it that way. Cosine of theta is x over r. Well, x is -2 and r is still the square root of 13. So there we have it. And then tangent of theta is y over x, which is 3 over -2, which sure, we just write that as -3/2. And there we have them. So to get the other 3, remember, they're just reciprocals, right? We know that cosecant is the reciprocal of sine. And we know that secant is the reciprocal of cosine. This should have been a 3. And we know that cotangent is the reciprocal of tangent. So there we go. So still the same conventions that we used before. Focus on sine, cosine, and tangent, use those to get the reciprocals. So there is a glimpse into how we find the trig functions of angles that terminate in any other quadrant other than quadrant 1. What we'll look at in a little bit here is, can we say that sine of theta is always going to be positive in certain quadrants, cosine, tangent, whatever? And it turns out we have a really easy way to remember that, so stay tuned for more.